So this is the variable volume that we're going to be spending a lot of time measuring. Volume is simply the amount of space that an object takes up or occupies. Or it can also be the amount of space that an object can hold in the case of a container. Like a 2-liter soda bottle can hold the volume of 2 liters worth of soda. If you take a look at a rock, doesn't matter what size it is, that rock or any object is going to take up a certain amount of space. No two things can occupy the same space at the same time, but all objects are going to have a volume to it. The common units are liters, and we will oftentimes use milliliters. We're going to do a lot of measuring in milliliters. The bigger the object is, the more space it takes up. This big hot air balloon right there has more volume than this little tiny party balloon. So it has a bigger volume because it takes up more space than the little balloon. If you're measuring a solid and you can simply get its length, width, and height by using a ruler or a meter stick, you can find the volume of that object by multiplying the three of them together. So the units would be cubic meters, and I'll show you an example. There's that same box. So let's say the length is 4 meters, the width is 1 meter, and then 2 meters is the height of the box. You just simply multiply these together. 4 times 1 is 4, 4 times 2 is 8. It would have a volume of 8 cubic meters. So you're taking meters times meters times meters. Every time you do that, you end up adding 1 to the superscript up here. Okay, so meters times meters, if you were doing area, a length times a width, you would end up with meters squared. In this case, because we have 3 dimensions, meter times meter times meter, that gives cubic meters. Now if we converted those into centimeters, you'd have 400 centimeters, 100 centimeters, and 200 centimeters. So multiplying those together, you get 8 million cubic centimeters, or what a lot of you are familiar with is cc's. In fact, when you look at or watch a show, like a doctor show or an emergency show, they might say, oh, we need to have so many cc's of this medication to inject into the patient. 1 cc is equal to 1 milliliter. And those of you interested in dirt bikes or any types of engines at all, or mopeds, you buy or a motorcycle. If you get a motorcycle and it's a 500 cc, what that means is the actual engine, the solid part of the engine, is 500 cubic centimeters worth of volume. If you have a liquid to measure, you need what's called a graduated cylinder. And they call them graduated cylinders because, number one, it's a cylinder, so it's round. If you were to look at the top here, you'd find a circle, and it's over that circle has a certain height to it. So that cylinder has graduations in it. And what a graduation is separations. So each one of these lines that you're seeing here is a separation from 1 milliliter to the next. And this one happens to be 50 milliliter total of volume that it can measure fairly accurately. The larger the graduated cylinder, the more error there is with that cylinder, and the smaller it is, the more accurate it is. Okay, so bigger cylinders are not as accurate as smaller ones. So those graduations, by the way, just a little side note, you graduate from high school, you graduate from 8th grade going to high school. Well, you graduate every single year that you're going through school. So a graduation just means a separation from one to the next. When you measure a volume of a liquid in a graduated cylinder, the graduated cylinder has, the liquid has a curve in it. And what we're going to be measuring a lot of is water. And water has the property of it tends to be sticky. So it will stick to the side. And as a result, you get a slight curve. That curve is called a meniscus. And so in order to standardize measuring, you could measure on the left side, you can measure on the right side, you can measure the top or the bottom. So to keep everything standardized, you want to make sure that when you're using a graduated cylinder that you're always measuring the bottom of the meniscus, the lowest part. In order to do that, there's a couple of ways that we could do it wrong, and that could be that you're holding the graduated cylinder up off the table. It could mean that you have the graduated cylinder on the table and you're looking down. All of those are going to give you inaccurate results. So the best way, the most accurate way to get the most precise measurement from the graduated cylinder is at eye level. And what this boy is doing right here is he's keeping it on a level surface and he's getting down. Notice you can't see any of his body because he's getting down, and his eye is right at the level of the meniscus. That's the most accurate way of getting the volume using a graduated cylinder. Now sometimes things aren't as easy to measure with a ruler, and you can't just simply put them into a graduated cylinder. So we have what's called displacement. And if you think about displacement, when you fill up a bathtub, if you were to fill it up all the way and you were to go into the bathtub, so the water level's all the way at the top, and you get into the bathtub to take a bath, you're going to make a mess because no two objects can occupy the same space at the same time. So you're going to displace the water that would normally be where your body is, and that water is going to spill out. So by taking an irregularly shaped object and using, in this case, this is like a displacement container, you fill up this water. We have one very similar to this that you're going to have access to try. This water is all the way up to the top. Any water that is displaced is going to pour out and into this cylinder for you to measure. So if you were to put a rock or any other object in here, this water is going to get displaced. The amount of water displaced is the same exact volume as what that object is. So they used to do this with car engines and motorcycle engines and dirt bike engines. They would put the engine into a big huge container of water, and they would have special ways of collecting the water, and the amount of water displaced was equal to the size of the engine. So you had a way of comparing engine size and, you know, getting a rough idea of which one was more powerful. Now, if you have a smaller object that can fit into a graduated cylinder, you don't need any fancy container. You just use the graduated cylinder. So in this case, you have a rock. And you start off with a known volume. So that looks like it's about 200 milliliters of water. You put a rock in, whatever amount of water level, whatever the level of the water is when you put the rock in, that's the ending volume. So if you can just simply subtract the two of these, so that's what I have over here, 265 milliliters, subtract the original 200 milliliters, then 65 milliliters is the volume of that rock. Okay? And just remember, I know it says cubic centimeters up here. You won't see cubic centimeters in our graduated cylinders, but 1 milliliter is equal to 1 cubic centimeter.